beautiful people, and welcome. In this video, we're talking about the rational root theorem. We're going to talk about this, how to derive roots from the rational root theorem, and also how to see if these zeros are in fact going to be factors of this polynomial or these polynomials. As always, I am human, so if I make a mistake, that's okay. Let me know where the mistake occurs so that way I may fix it. All right, beautiful people, let's go ahead and start with the actual rational root theorem. So the rational root theorem states if p of x, so if the function p of x is a polynomial function with integer coefficients, and if m divided by n is a zero of the polynomial function, then m is a factor of the constant term p of x, and n is a factor of the leading coefficient of p of x. So what the heck does that mean? So let's say you have a polynomial. Let's do an example. Let's say you have a polynomial and we'll call this polynomial p of x. Ooh, that's an x. Call this polynomial p of x. So this polynomial with integer coefficients, what that means is that these are integers. Now x does have a number in front of it, we just can't see it because mathematicians are lazy and so we don't want to write that. But there is a coefficient of 1, so these are all integer coefficients. Then m is a factor of the constant term and n is the factor of the leading coefficient. So this is the leading coefficient. And leading coefficient is the coefficient of the highest term, or let's say of the leading term with the highest exponent. So the highest exponent is 3. The leading coefficient of that term is 1. And then, so this would be your n. And then the m is a factor of the constant term. So constant term is the term without any variables. And your constant term is, what is it? M. I hesitated there for a second. And this is constant. And so once we have the leading coefficient and the constant term, so what happens with it? We have m divided by n, but we're talking about factors. That's like the super duper important part of this, is we're talking about factors. Factors is the undoing of multiplication. So when we list out factors, we're listing out every single number that goes perfectly into that original number. So let's go ahead and find out what this would look like. So if I have m divided by n, I'm going to make a nice long bar, and I'm going to write the factors of 20 and the factors of 1, meaning what times what is 20. If I was to do this on my calculator, what I would do is I would double check what all of these are. So I know that 1 goes in it because 1 times 20 is 20. I also know that negative 1 goes in it because negative 1 times a negative 20 is 20. I also know 2 goes in it because 20 divided by 2 is 10. I also know that negative 2 goes in there because negative 2 times a negative 10 goes in there. I know that 4 goes in there. 4 times 5 is 20. I'm running out of room. I'm going to write it here. And then I also know that negative 4 goes in there because negative 4 times a negative 5 goes in there. And that's about it. After that, next thing we have is 10. 10 times 2. So I'm only writing numbers once, but notice that I have the positive and the negative of that number. So now, what are the factors of 1? Well, 1 times 1 is 1. I'm only writing 1 once because 1 times 1. And then I also know that negative 1 times a negative 1 is equal to 1. So how does this look like simplified? So I know my factors are going to be plus or minus 1. I have a plus and a minus 1. I have a plus and minus 2. I have a plus or minus 4. I have a plus or minus 5. I have a plus or minus 10. I have a plus or minus 20. Then on the bottom, I have a plus or minus 1. So what the heck does this mean? What does this all mean? So these are all the potential zeros. So let's go ahead and write out the potential zeros. Now, zeros or potential x-intercepts, right? So potential zeros. Now, how does it look like? Because I have a bunch of numerators up top separated by commas, and I have 1. So this is where the fun really truly begins. What happens is you need to create all of those. So I'm going to say I have plus or minus 1 divided by 1. I have plus or minus 1. I have plus or minus 2 divided by plus or minus 1. So I'm basically creating all of these fractions. So if there was another number in the denominator, we'll do another example. We would do this twice. If there's 3 denominators, we would do this 3 times. So I am writing out, these are all of my possible zeros, all of my potential x-intercepts. Okay, so again, there's so many plus or minuses. Let's go ahead and simplify that. So I have plus or minus 1, comma, plus or minus 2, and I'm simplifying these fractions. The plus or minus still stays because you can have a positive number or you can have a negative number. So when it's asking you what are all of the possible zeros, these are all of the potential zeros for the given polynomial. Now remember, zeros are just x-intercepts. These are all the possible. We'll do another example with a denominator that is different. So let's do example 2 for all possible zeros. I have 6x cubed plus 11x squared minus 3x minus 2. Sometimes you'll see it equal to p of x, f of x. Sometimes you'll see it equal to 0. So let's go ahead. This is my n. This is my m. M over n. So again, I'm listing all of my factors. So what are my factors of 2? What are my factors of 6? So 1 times 2. Again, it's always going to be plus or minus. 1 times 2. And 2 times 1, those are the only factors here. I'm going to separate that with a comma. Now on the bottom, what are my factors of 6? I know I have 1 times 6. I have 2 times 3, and that's it. So notice now I have 4 denominators and I have 2 numerators. So how would that look like? Each numerator has to be on each denominator. So what I do is I say I have 1. Again, it's always going to be plus or minus. I have 1 over 1. Then I have 1 over 2. Then I have 1 over 3. Then I have 1 over 6. Remember, all of these are plus or minus. And then now I have another numerator. So now I have 2 over 1, 2 over 2, 2 over 3, and 2 over 6. Again, all of these are plus or minus. These are all of my potential zeros. Let's simplify this, make this prettier. 1 divided by 1 is just 1. I have a 1/2, I have a 1/3, and I have a 1/6. Then I have a 2 over 1, so I have a 2. I have a 2 divided by 2, that's 1. I already have a 1 here, so I'm not going to write it. Then I have a 2/3, and I have a 2/6, which simplifies to 1/3. I already have a 1/3 here, so I'm done. So all possible zeros, I have plus or minus 1, comma, plus or minus 2. Usually the whole numbers go first. And then I have plus or minus 1/3, plus or minus 1/6, plus or minus 2/3. These are all my potential zeros. That doesn't mean all of them are my zeros. It means one of these, either the plus or the minus of that, would be a 0. All right, so how do you know which one is a 0 and what does that mean? Using the rational root theorem, we can determine if something is a factor. So how do we use the rational root theorem? So step number 1 is list out all possible roots. Now roots are the same as zeros, which are the same as your x-intercepts. And how do you do that? Is you're taking your m over your n. Your m is your constant factors. And your n are your leading coefficient factors. So once you have all of your possible roots, all of your possible zeros, step number 2 is take one, again, at a time, a possible 0, substitute into the given equation, check if it simplifies to 0. So if it does simplify to 0, then yes, it actually works. And from here, we can create the factor. And remember, that's the opposite bubble. So if it does not equal to 0, you're basically done. Keep trying. Other potential zeros from step 1 until you get one that does equal 0. Right. Now, this is one of the ways that we're going to be teaching you. There is another way. So if you want the other way, reach out to me. You and I can chat a little bit. There is another way where it involves synthetic division. We're going to hold off on synthetic division just for a little bit. I'm going to introduce synthetic division to you, but we're not going to go in depth with it since long division works every single time. Here, you can use synthetic division to check if something is a factor, if something is a true 0. However, we're going to use the polynomial method of substituting and plugging it in. All right, let's do an example. If you need this, I recommend pausing this video so you can write all of this down. This is step number 2. This is step number 1. And let's go ahead and do some examples. All right, so given the following polynomial, so here's the polynomial. It's the same polynomial that we used previously to identify all of our zeros, but we're going to do that all over again. So given the zeros, find a factor. All right, so step number 1, m over n. This is your m. This is your n. We're going to list out the factors. We're going to do this a little bit quicker this time since we did just do it. This is the factors of 2, factors of 6. And then what did we get from here? We got our potential zeros. Again, zeros are roots, are x-intercepts. These are our possible zeros. We had plus or minus 1, plus or minus 2, plus or minus 1/3, plus or minus 1/6, and plus or minus 2/3. Now what that means is you're going to, for each one, have to check a plus or minus, plus 1 and a minus 1. Let's try that again. Let me erase that and you can do that. So you're going to have to check a plus and a minus for both. So you're going to check a plus 1, you're going to check a minus 1. Then you're going to check a plus 2, you're going to check a minus 2. You're going to stop when you get to your first 0. So for example, let's go ahead and take our polynomial. And I need to see if p of x, if we go back to our definition, we want to see if p of our fraction is going to equal to 0. That's what we're trying to do. So 6 times, I'm going to try positive 1 first. So anytime I see an x, I'm going to put parentheses and I'm going to put a potential 0 in it. I'm going to use my calculator if you need to. I don't think you're going to need to for this one. If it gets to like these fractions, you probably will need to. We're starting with whole numbers and we're starting with the smaller whole numbers because we really want those to work out. It's going to be a lot easier than dealing with fractions. All right, so what do we have? We have 1 cubed, that's 1. 1 times 6 is 6. Plus 11 minus 3 minus 2. So we have 6 plus 11 minus 3 minus 2, and that equals to 12. So that does not equal to 0. So we know, what does this tell us? We know that 1 is not an 0. Or a root. So that means the factor of the opposite x minus 1 does not exist. It's not a perfect factor. It doesn't go in it. It's like saying, you guys, it's like saying, you know, we have 6 and I'm checking 5. 5 is not a factor of 6. 5 times something weird is 6, but however, 5 is not a perfect factor of 6. All right, let's try another one. So again, I'm going to just switch colors so that way we can tell the difference. Let's try negative 1. This is why you use parentheses because especially with like negatives, it's easier to mess up. So I have negative cubed, that is a negative, so I have negative 6. Negative squared, that's positive. Negative times a negative, that's a positive. And minus 2, p of x. And we're going to type that in. Negative 6 plus 11 plus 3 minus 2. And that gives me p of x is equal to 6. So again, this is not equal to 0. So what does this tell us? It tells us the x-intercept of 0, 6 does not exist. So the factor of x minus 6, again, we're doing the opposite bubble, does not exist. It does not exist. All right, let's try another one. I'm going to jump a little bit and I'm going to do negative 2. Oh, negative 2. All right, so what do we have? We have this one I am using my calculator. Ooh, be careful on your calculator. You have to type in parentheses, then cubed. Make sure -2 is in parentheses or else it's going to give you something wrong. So I have -8 times 6, which is -48, plus 4 times 11, that is 44, plus 6 minus 2. So I have -48 plus 44 plus 6. I'm multiplying instead of dividing on my calculator. Plus 44 plus 6 minus 2. And that, in fact, does equal to 0. So 0 is equal to p of x. So what does that tell us? We're doing a happy dance here. That tells us that, yes, you have an intercept, again, x-intercept, at -2, 0. Oh, I think I wrote that wrong. We have an x-intercept. That should be 6.0. Hopefully you caught that. So we do have an x-intercept at -2, 0, and a factor of x plus 2. Again, do the opposite bubble. That's a 2, not a 3. Does exist. That 2 is giving me a little bit of a headache, so let's go ahead and change it, make it prettier. So that factor does exist. So what do we do with that factor? So now that you know that you have a factor, you can use long division to find, or synthetic, depending on if you have me as a teacher or not. Use long division to find the other factor. So for example, now that we know we have x plus 2, well, x plus 2 times what is our polynomial of 6x cubed plus 11x squared minus 3x minus 2. So what is this? So we're going to use long division. So we're going to say 6x cubed plus 11x squared minus 3x minus 2. We're going to divide that by x plus 2, since we know that that's the factor. And we're going to find out what our answer is. I'm not going to do that in this video. That is a separate video on dividing long division, dividing polynomials by long division. But that is it for the rational root theorem. You're going to need to know two things. You're going to need to know how to identify the zeros, the potential zeros or the potential roots. You're going to need to find out which ones are in fact zeros, which ones are roots. And then you're going to have to find the opposite bubble or the factor of what is being multiplied to actually get our polynomial. Thank you so much for watching my video, and I will see you in my next one. Bye.